Alright, welcome back everybody. In this video we're going to look at example 2 from the More with Taylor series lesson. But we'll start by looking at this little table that you see on page 2. This is a listing of common Maclaurin series that we've encountered already and their intervals of convergence, and a few that we might not have encountered already. The first two we encountered way back in the beginning of our study of infinite series, and we developed these Maclaurin series from the idea that these were geometric. So you should know the series for 1 over 1 minus x and the series for 1 over 1 plus x. The next three in the list are the ones that the College Board actually says that you need to know these cold for your AP exam. The series for e to the x, the series for sine of x, and the series for cosine of x. And they will frequently expect you to be able to develop a series based off of one of these on a free response section or in a multiple choice question, to be able to just know this series and then develop another series through multiplication or substitution or one of the other techniques that we've already looked at for developing series based off of a known series. And then here are a couple more below that that you should know, that I would recommend you know. A series for the natural log of the quantity 1 plus x, which we actually just got by integrating the series for 1 over 1 plus x. And then also there's a series here for the arctangent of x. That it would be nice if you knew that as well. Alright, so let's put these into practice and look at how we're going to use these, and we'll start with example 2. Using the common Maclaurin series, we're going to write the Maclaurin series for each of the following and identify their interval of convergence. So the first series we're trying to find is for cosine of 2x. Well, we know the series for cosine of x. Cosine of x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, etc., etc., with a general term of negative 1 to the n, x to the 2n over the quantity 2n factorial, with an interval of convergence of all real numbers. So to find the series for the cosine of the quantity 2x, all we're going to do is substitute 2x in here everywhere where there is an x. So we've got 1 minus 2x quantity squared over 2 factorial plus 2x quantity to the 4th over 4 factorial, etc., etc. And then 2x to the 2n over 2n factorial. And what I'd like to do is just simplify this and clean it up a little bit in the early terms. So we've got cosine of 2x equals 1 minus, and that's going to be 4x squared over 2, which is just 2x squared. And then the next term is going to be quantity 2x to the 4th. That's 16x to the 4th over 24, or 2/3. X to the 4th, and then I might leave the general term exactly as it is, or depending on how I'm feeling that day, I might split this into 2 to the 2n, x to the 2n, all over the quantity 2n factorial. And there's a Maclaurin series for cosine of 2x. Now, since the interval of convergence for cosine of x was all real numbers, that's going to stay the same for this series, and so my interval of convergence is going to be all reals. Alright, let's go on to part B. There we go, there's my page turn. Alright, here we're going to write a series for 1 plus the sine of 2x. And this is going to take us a couple of steps to develop. We start with the series for sine of x. And the series for sine of x is x minus x to the 3rd over 3 factorial plus x to the 5th over 5 factorial, etc., etc. And then negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Okay, so we're going to break this down piece by piece. The first thing we want to do is find a series for the numerator, and within the numerator we want to find first a series for sine of 2x. So we'll find the series for sine of 2x by substituting 2x in here everywhere where there's an x. So we've got 2x minus quantity 2x to the third over 3 factorial plus 2x to the fifth over 5 factorial, etc., etc. And that's going to be then 2x to the 2n plus 1 over 2n plus 1 factorial. And there's a series for sine of 2x. Then we're going to do the yellow highlighted series, which really is quite simple. All we're going to do is take the series for sine of 2x and add 1 on the front end. And there's a series for 1 plus the sine of 2x. And then the last thing I'm going to do to this series is divide everything by 2 to get a series that represents 1 plus the sine of 2x all over 2. So I'm going to divide each of these terms by 2. It's 1/2 plus x. And then when I divide this by 2, maybe I should expand it out. I've got 8x to the third over 6. So now it's 8x to the third over 12. It's 2/3 x squared. And then I've got 32x over 5 factorial, 32 over 120, now 32 over 240, which is 16 over 120, 8 over 60, 2 over 15, I believe. I'm doing this quickly, so pardon me if I made a quick arithmetic error. I want to save time for what's going on in the future. And multiplying this by 1/2 in the general term is just going to turn this into 2x to the 2n power. Sorry. Come on, eraser. Let's go. All right. It's going to turn this into 2 to the 2n power times x to the 2n plus 1 all over the quantity 2n plus 1 factorial. And there's a series for 1 plus sine of 2x over 2. All right, let's go on to part C. A series for 3x times the natural log of, interval of convergence up here is going to be all reals again, since the interval of convergence for sine was all reals. All right, next, 3x times the natural log of the quantity 1 minus 2x. We've got a series for natural log of the quantity 1 plus x. That's x minus x squared over 2 plus x cubed over 3, etc., out to a general term of negative 1 to the n minus 1 times x to the n over n. All right. And then we'll take our series and modify it to a series for natural log of the quantity 1 minus 2x. By substituting negative 2x in everywhere where there's an x. That's 4x squared over 2, so that's going to be 2x squared. And that's negative 8x to the third, negative 8/3 x to the third. And negative 1 to the n minus 1 times negative 2x to the n all over n. And we might want to simplify that general term, but I'm not going to simplify that general term right now. Let's keep plowing forward. To get a series then for 3x natural log of the quantity 1 minus 2x, all I'm going to do is multiply all of these terms by 3x. Gives me negative 6x squared minus 6x to the third minus 8 x to the fourth, etc., etc. And all these minus signs work out to be just a minus 1. So I can get rid of the negative sign here and the negative 1 to the n minus 1 and just change this over to 2x to the n. Let's make it 3 times 2 to the n x to the n plus 1 all over n. Now, as far as my interval of convergence goes, my interval of convergence for the original was negative 1 is less than x is less than or equal to 1. So if we substitute negative 2x into that, we can find the interval of convergence for our new series. And that's going to be negative 1/2 is less than or equal to x is less than 1/2. So this is our interval of convergence. All right, one more, part D. A series for 2x squared e to the negative 3x. We start with the series for e to the x. That's 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and a general term of x to the n over n factorial. And so to get a series for e to the negative 3x, I just substitute negative 3x in there everywhere. Let's see, negative 3 to the third is negative 27 over 6, so that's going to be negative 9/2. We'll make that negative 1 to the n times 3x to the n all over n factorial. And then when we multiply this by 2x squared to get our final series, we're just going to take each of the terms and multiply them by 2x squared. Negative 1 to the n, 3 to the n, x to the n plus 2 times 2 all over n factorial. And I have the option here, and I'm not going to do it in this video, but I have the option to recalibrate that general term in such a way that it makes the first term that we see here the 0th term. Actually, I already have that. Good. Good for me. All right, and then the last thing I need is the interval of convergence. Since the interval of convergence for e to the x is all real numbers, the interval of convergence for this one will also be all reals. All right, so that's how we can use some common Maclaurin series that we already know to come up with Maclaurin series for more complicated functions. And undoubtedly we'll do more of that in the future. See you guys next time. Have a great rest of your day.